Lesson 3.2, Translations. This lesson starts out with like a little descriptive activity. So it says, draw a copy of ABCD, the polygon ABCD, on the grid in a different location. So they are saying to trace it or copy it on a graph paper or on this exact same graph, and you can use these points and segments somewhere else, but it has to look exactly the same, just in a different location. And then it says, on a sheet of paper, write the instructions. You can write them down here in your notebook if you would like, or in the notebook, your student companion book. But basically, you need to describe how to move it. How do you move that exact shape without messing up the actual shape? And then this part, unless your teacher decides to do this part we're going to skip because we're not live, but it says to exchange your instructions to another student and compare and see how they're different. But this part B, you might not do unless you're live in class. And how to communicate precisely. When you give instructions, you have to make sure someone who doesn't understand how to do this or has never done it can do it. So that when you give instructions, just double check. And that's why communicating precisely is so important. Translations. A translation, whatever the figure is, it is literally a slide. But that slide or movement has to preserve the shape, has to preserve every angle and every side length. So it doesn't slide and get bigger and this triangle gets bigger or smaller. It preserves the side lengths and the angle measures and just moves. And so when you look at this visual, this movement of point A to A prime, B to B prime, C to C prime, these dashed segments will always be congruent because you're moving each point A, B, and C the exact same distance. If you move them different distances, then you wouldn't have the original shape. It'd be like all messed up and crooked. So you have to move every single shape in the exact same amount. That's what this says. Each of the segments is congruent. And then also, if you notice, these segments are not only congruent, they are parallel. That is true in every translation. So you're going to find the image of a translation. So it starts out with triangle EFG, and you need to move it to EFG prime. So there's the original triangle or pre-image, and then it has this notation. Notice the capital T, that stands for translation, and then these numbers. So just like a coordinate where it's like X and then Y, this 7 associates with the X and the -4 associates with the Y value. So if you look at each point, you are going to move each point X value a +7, meaning 7 in the positive direction, which would be to the right. And this, the Y, you're going to go -4, which means down 4. So let's go through each of these steps. So you already have the original or pre-image. If you start with point E, and I went 7 to the right and down 4, there's point E prime. And hopefully you'll be able to do all the rest as well. F, 7 to the right, down 4. +7, -4. And when you have all 3 points, or however many points you need for the figure, then you connect it and make sure to label the points with the prime, EFG prime. You're going to try it now too. You can do this right on this figure or in your notebook on the try it. So try to figure out what the 6 means. Remember, the first number has to do with X, and then the -7, that has to do with the Y. And then you can visually draw it or just describe it or create it in your notebook. And also here. Same exact problem, just moving it in a little bit different way. So the translation is +11 and +2. And I know it's positive because there's not a negative there. So any number that doesn't have a negative will be a positive. Here is the translation rule. Now you are going to write the rule. On the last slides, they had the little X value, Y value, what was happening. But this one, you have to write the rule. So let's look at S and S prime. How did I move or translate from S, the pre-image, to S prime? So notice I went 1 to the left, or this point goes 1 to the left and 1, 2, 3, 4 down. So you have to ask yourself, would that be a positive? Would that be a negative? So let's look at this solution. So they say take one of the points and the corresponding points, which ironically they chose S as well, And they said, basically, figure out how they're different. So they took, I'm going to see if I can get this right there. They took this value, the x value is -5. The y value of s, or the x value of s prime is -6. So they're just looking at the x values. What's the difference between -5 and -6? That's 1. On a graph, I didn't do that math. I just counted. So if you have the pre-image and the image, just count. How much did it move left or right? How much did it move up or down? And then you can create your rule. But if you don't have a graph, then you would have to find the difference of each of the points. So let's look at the y. Let's pretend we don't have the graph, and I just have this point here, s. The y value is 6. S prime, the y value is 2. 6 minus 2 is 4. And you have to figure out, are you going up or down? You're going down. And that's what I counted. 1, 2, 3, 4, going down. So the rule would look something like this. Translation, left 1, down 4. It does have a graph, but try it without counting. Try to do the calculations. What's the difference between -3 and 2? What's the difference between 1 and 3? And figure out, are you going positive or negative? And to double check yourself before you write the rule, go ahead and count. Okay, from P to P prime, 1, 2. Okay, it goes up 2, so positive for the y value. 1, 2, 3, 4, 5. Positive 5 for the x value. So, and it doesn't matter which one you do first. Just make sure the x's go in the first part of the coordinate and the y's go in the second. Okay, composition of rigid motions. Composition is something that you do in algebra a lot, especially in algebra 2. It's a composition of a function where you do one part of the function, and then once you get that answer, you put that answer into another function. This is the same idea. So you're going to do translation of this triangle. So translate it -2, 5, and then you're going to reflect it over line L. That's an example. So you first start with whatever is closest to the middle of the parentheses. So you start with this triangle and move your way out, the translation. And once you translate that shape, then you'll have a reflection. So oftentimes you have the pre-image, the image with prime, and then the image again with double prime. So you'll have 2 little markings on there. So the composition is this more than one transformation. So learn how to dance. Kyle moves from position A to B and then C. See how you start a pre-image and then an image and then another image of that. So that's a composition. So to do this, I want you to just think of this as a graph. From point A, how much do you move left or right? So that would be like the x value. Let's see, 1, 2 to the right, and then 1, 2 up. So let's look at the rules and what they say. 2, 2, 2 over, 2 up. And then from point B, so like A is done. From point B, how did you move from B to C? To the right 1, down 1. Here it is, translation. From the right 1, down 1. So that's the composition. But overall, how did you get from visual A to visual C? So skip the middle, whatever movements happened, you want like the overall rule. So that's when you put these 2 rules together. So I want to show you how they do this. So they find the composite function, 2, 2, and then 1, -2, 1, -1, and then they put them together. So when you apply both of them, do this answer, and this is what it means. It says, overall, it went to the right 3 and up 1. So let's go check what that means. To the right 3, 1, 2, 3, up 1. So no matter what happened, no matter how many steps are in the middle, from A to C, how did you get there overall? Okay. But you do have these middle steps in between that you might need to report or to figure out the notation for. Try that a couple times. See if you can do that. Here's a try it. So composition, that little circle, composition function. So it says, what is the composition of the translation written as one transformation? It doesn't give you a visual. You don't have anything to look at. But if you went 1 to the right and then 3 to the right, how much would you go to the right overall? If you went -1, that means to the left. down 1, and you went -2, down 2, how much total would you go down? And then you would write one thing that looks kind of like this with a capital T and the XY coordinates of overall what you would do. And you're going to do it here as well. Overall, you need to understand what a translation is, how you read the notation with that capital T and the coordinates. Can you identify the translation by looking at a graph or looking at coordinates? And can you write the rule of a translation based on a graph or coordinates? Good luck.